In this video, I'm going to show you how to get started with this 3.2-inch ILI9341 TFT display using ESP32. We'll go through the wiring, libraries, some basic code. We'll cover the touchscreen input as well. In my last video, the CYD cheap yellow display took the top spot, but since then, this setup has become my personal favorite. The ESP32 inside the CYD is a little limited and doesn't include any PS RAM. This extra memory lets us build much more advanced projects, full UI systems, smooth graphics, and even full video games with animated sprites. First, let's take a look at how this display communicates. Like most TFT screens, it uses SPI, or Serial Peripheral Interface. This is a fast communication protocol that allows the ESP32 to send data using just a few pins. Make sure to follow the wiring diagram on screen exactly for both the TFT and the touch controller. If you're using an Arduino instead of an ESP32, you'll need to use a logic level shifter, since this display runs at 3.3 volt logic and power. The next step is the library. We're going to use the TFT ESPI library, which is one of the fastest and most optimized libraries for this display. Instead of manually configuring everything, let's make this a little easier. Let's just take the pre-configured user setup.h file I've provided and replace it with the one inside your TFT ESPI library folder. This file already has the correct driver and pins set up, so you don't need to mess with any manual configuration. Once that's completed, we're ready to start drawing to the screen. Now let's look at some code. Let's start with a simple demo sketch. We'll initialize the display and draw some basic text and shapes just to confirm that everything is wired and working correctly. You'll immediately notice how fast the screen updates. That's one of the biggest advantages of SPI combined with this library. You can find any code seen in this video in the link in the description. Now let's take a look at the touch input. This display uses a XPT2046 touch controller, which is a resistive touchscreen, not capacitive like your phone. This means that it responds to pressure, so you can use your finger or a stylus to interact with it. To read the touch input, we get the raw X and Y values from the controller, but those raw values don't necessarily match the screen directly, so that's where calibration comes in. We're going to use a simple mapping system to convert raw values into screen coordinates. For example, raw values might range from around 200 to 3700, and we map that to the screen resolution of 320 by 240. These minimum and maximum values may need slight adjustment depending on your specific display. Once that's set up, touch handling becomes very straightforward, and I use the same setup for every sketch. In this simple dashboard example, we can check whether the touch position is inside a certain screen area. So when I tap a button on the screen, it triggers an action in the code instantly. From here, we can push things further and build interactive projects, including games with animated sprites. If you want to see how to display GIFs on the screen, check out this video linked here. In this example, we're loading frames from the SD card into PS RAM, so they're instantly ready with no lag, smooth playback, and fast response. This is how you get started with this 3.2-inch TFT display using ESP32. If you found this helpful, make sure to subscribe, and we'll see you in the next one. Thank you.